Hi, welcome to all. Welcome to Unacademy. So all of you know that Unacademy is the India's largest online learning platform. I'm welcoming you all to this online beautiful platform. We are happy to announce that now we are going to providing the classes to the students who are appearing for their GATE and engineering service examinations. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada. My specialization is in VLSI. See, first we check how to get the Unacademy learning app into your device. If it is in your device, it's good. Otherwise, install it. Just go to Play Store in your device. Type the name Unacademy. Then you get the Unacademy learning app like this. Then you get the app like this. Okay, here corner bottom there you get a button, install button. Just click on that install button. Click on that install button. It will install the Unacademy learning app into your device. Okay. Now, once you open that Unacademy learning app, in that you get the top different courses available in that and top educators who are handling the different subjects in each course. You get that information. At the same time, you get a brief introduction about the top educators who are taking the classes in Unacademy. So here you can observe few of the top faculty. Here top faculty you can please verify the top faculty. Tiwari sir, he is a IIT topper. Ankit Goyal sir, he is the All India topper 1 in GATE 2 times, electrical department. Okay, and he got the prestigious President of India gold medal in IIT Indore. Okay, and Jain sir is the top computer faculty. Jaspal Singh sir is the IAS All India rank 4. He got his ex-IAS officer. Okay, and here are few more top faculty who are handling the classes in this. Okay, now so here are few more faculty from different departments. Now we are happy to announce that recently we started two batches for we started two different batches. One for GATE 2023, other one is for GATE 2023. So there is a SN batch for GATE 2023. This is mechanical engineering. Okay, and this batch started from 8th February 2021. Here are the top faculty who are handling the subjects in this. Okay, here are the top faculty who are handling the subjects in this. Okay, and this batch started from 8th February. Next there is a eval batch for GATE 2022 mechanical engineering. This batch started from 8th February 2021. Okay, and this batch also started from 8th February. So next we move to civil engineering. There is a ascend batch for GATE 2023 civil engineering. This batch started from 8th February. 8th February this batch started from. And there is a eval batch for GATE 2022 civil engineering. This batch started from 8th February 2021. And don't forget to use my code during subscription. So my code is VRAW10. By using this code during subscription, you get a 10% discount. You get 10% discount. Next, there is a eval batch for GATE 2022. This time this is for computer science and information technology. Here are the top faculty you can observe handling these subjects in computer science and engineering. This batch started from 8th February 2021. Again, there is a Ascend batch for GATE 2023. This is for electrical engineering, and this batch started from 1st February 2021. Here are the top faculty you can observe who are going to handling these subjects in this. And again, there is a Ascend batch for GATE 2023. This is for electronics and communication engineering. This batch started from 1st February. Okay, here are the top faculty who are working on this. Just please be online, just 1 minute, please. Sorry for interruption and sorry for delay. Yeah. Now, there is a SN batch for GATE 2023, Electronics and Communication Engineering Department, and this batch started from 1st February 2021. And here are the top faculty who are handling the classes in that. And again, there is a eval batch for GATE 2022. This is for electrical engineering. This batch started from 1st February. So here are the top faculty who are handling the classes in that. Okay. And this batch started from 1st February. And again, there is a eval batch for GATE 2022. This time this is for electronics and communication engineering. This batch started from 1st February 2021. And there is a eval batch for GATE 2022. This is for chemical engineering. So if any of your friends are from in chemical engineering side, please inform this one to them. Outside, it is a very difficult to get the training for GATE for chemical engineering. Okay, they must thank to Unacademy to provide such a beautiful facility to them. And this batch started from 25th January. Now, just we look on it, what are the different disciplines available in engineering for GATE and engineering service examinations. There is a mechanical engineering, electrical engineering, civil engineering, production and industrial, instrumentation engineering, computer science and IT department, chemical engineering, and last but not least, electronics and communication engineering. These are the different engineering disciplines available in GATE and engineering service for examinations. And we have two subscriptions. First one is a plus subscription. It is the basic plan. The second one is iconic subscription. It is the next level of the plus subscription. It is the next level of the plus subscription. Okay. So it will take your preparation to the next level by providing a personal coach to you. By providing a personal coach to you, it will take your preparation to next level. There are few commonalities between this. Now that is your classes are going to be handled by India's best educators in both the case. And there are interactive live classes, structured courses and PDFs they will provide, and live tests and quizzes. Now here you are going to differentiate live tests and quizzes. Okay, At this point here you are going to be differentiating. So that is, there is a personal coach we are providing in this. Now the purpose of the providing personal coach is, most of the students are busy with their regular curriculum in the college, third year and final year students, mini projects, seminars, projects, okay, internships, like that. They are very busy with their work. Okay, so at that time there is a need for whatever the test they are going to be writing, the test has to be analyzed properly. The test has to be analyzed properly. So once they've written the examination, whatever the test they've written, from that test they need to understand and they need to analyze in a proper way where they done mistakes and where they are strong and where they want more preparation. These basic things first they should know. To get this basic information, okay, students don't have much time. Now our personal coach is going to take care of all these things, okay, and he is going to prepare a proper study planner based on all these things, okay, and that study planner with proper material they will provide. By following these two properly, any student can get success in their examinations. Okay, so this is the basic difference between this one and that one, plus and iconic. Just a personal coach we are providing here. In addition to that, he will take the complete care of you, and exam to exam what is your progress. Okay, now based on that your preparation level they will estimate. Okay, they will guide, they will motivate. Okay, they will take complete care on you. That care is very very important. So next one is, in a plus plan, if you observe, we have different subscriptions. There is a 1 month subscription, 3 month subscription, 6 month subscription, 12 month subscription, 18 month subscription, and 24 month subscription. Okay, as a faculty I suggest take minimum 1 year subscription. By taking 1 year subscription you can analyze, study and prepare each and every subject thoroughly, and you can write more number of tests and you can revise the subject number of times, and you can estimate where you are strong and where you are doing the mistakes. Okay, all these things you can analyze properly. And don't forget to use my code VRAO10 during subscription. By using this code VRAO10 during subscription, you get 10% discount. After discount, it became 27,225 rupees. After discount it is. Next, we move to iconic plan. In iconic plan, there are two subscriptions: 1 year subscription and 2 year subscription. 1 year subscription and 2 year subscription. For 1 year subscription, it is 50,250 rupees. After discount, by using my code VRAO10 during subscription, it became 45,225 rupees only. Okay, and if you compare this amount with the amount what you are taking outside, what you are paying in outside institutions, okay, this is more or less close to that, but here you are getting more than that benefits. No need to move anywhere. Okay, what are the benefits you are getting there? Okay, more than that benefits you can get by sitting at your home itself. Okay, and especially personal coach we are providing to you. Regular classes are going regularly and personal coach is going to take care of about your things. How is your preparation? Okay, and how you are writing the examinations. For particular subject there is a weightage, high weightage. If you are facing some problems with that with that subject, you can interact with your personal coach. Personal coach will follow up that and forward that data to the proper faculty, and faculty will come and take the classes to you in that particular subject. So all these things, such type of things, okay, complete. So finally, at what level, at one level in iconic, your personal coach knows more about you compared to you. about yourself. He knows more than about you compared to you. Okay, so that is the intention to provide the personal coach, and don't waste your time. Whatever the thing is happened at outside, your learning process cannot be stopped. Okay, by enrolling in this, continue your learning process and get success. Don't waste your time. Thank you. Now we are moving to our today's topic. Our today's topic is problems on PN junction diode. Problems on PN junction diode. Now let us see this problem. Here, consider an abrupt PN junction. Let VBI be the built-in potential of this junction and VR be the applied reverse bias. If the junction capacitance Cj is 1 picofarad for VBI plus VR equals to 1 volt, then for VBI plus VR equals to 4 volts, junction capacitance Cj will be. So my dear students, we know one equation. Depletion region width already we defined. Its value is square root of 2 epsilon by q into 1 by Na plus 1 by Nd into V0 plus Vr applied reverse voltage. Whatever the V0 here we are using, they are saying that is the built-in voltage, VBI, built-in potential they are calling it as. Okay, from this, W is directly proportional to square root of VBI plus VR. Okay, now at the same time we know the junction capacitance Cj is epsilon A by W, depletion width. So from this we can write Cj is inversely proportional to depletion width. From the knowledge of these two, we can write Cj is inversely proportional to square root of VBI plus VR. We can write like this, Cj value. Okay, so once you written Cj value like this, now we can frame an equation from this, that is Cj1 by Cj2 is equals to square root of VBI plus VR2 by square root of VBI plus VR1, first case. Okay, now just I am substituting the values here. So Cj1 they given it as 1 picofarad by Cj2 you need to calculate equal to square root of VBI plus VR. So that is a second case, VBI plus VR value is 4 by square root of VBI plus VR, VBI plus VR1. In first case it is 1. Now its value is 2. Therefore, now we can write simply Cj2 is 1 by 2 picofarads. So that is 0.5 picofarads. 0.5 picofarads. Okay. So that is about your problem, Cj2. So your option is D. It was given in previous GATE examination. So my dear students, just follow the basics. Just follow the basics. Okay, and whatever the formulas you know, use those things. And based on that formulas, design the proper formula what we need to solve that problem. That is the thing what you have to do. Next one, I am moving to next problem. Yeah, see this. The doping concentration on the p side and n side of silicon diode are p side and n side. First they mentioned p side, that means this is going to be Na, and this is n side, that means it is Nd respectively. A forward bias of 0.3 volts, forward voltage they applied to the diode at 300 Kelvin. The intrinsic carrier concentration of silicon Ni equals to 1.5 into 10 power 10 per centimeter cube. The Ni value is 1.5 into 10 power 10 per centimeter cube, and Kt by Q is 26 millivolts. 26 millivolts. The electron concentration at the edge of the depletion region on p side is, see this. This is the case. For better understanding purpose, I am taking little bit separation to p region and n region. This is the p region and this is the n region. Under steady state, this is the minority carrier concentration, electron concentration in p region, and this is the whole concentration in n region. A forward bias of 0.3 volts they applied. Okay, now what they want is the electron concentration at the edge of the depletion region on p side. See, once a forward voltage applied, p positive, n negative, electrons are drift from n region to p region, that means injected. And once they injected, let us assume this much number is injected. Okay, this much number is injected and they diffuse. After injection, they diffuse like this. During the diffusion, the electron concentration is decreasing due to the recombination in it. Okay, now they want the electron concentration at the edge of the depletion region on p side, how much it is. They want this value, how much it is. Okay, now I am going to representing that value is n dash of 0 at the edge. It is at edge, its value is n dash of 0. Okay, just a minute, we go back to the diode current equation. Okay, and from the current equation we get that value. See this. Now I am going to diode current equation. So this is a PN junction, P region and N region, steady state minority holes and steady state minority electrons in P region and N region respectively. And let us P plus N junction, holes are injected into the N region in forward bias. Once this much number of holes are injected, and they are going to be, due to high concentration of holes here, less concentration of holes here. Holes are diffused this side, they are moving this side. Recombination is taking place. Now let us, this value is p dash of 0, we mentioned already in previous case. Okay, now we need the value of this in this problem. Okay, we derive a little bit diode current equation, from that we get that value. See, during the derivation of diode current equation we got that. For your better understanding purpose, once again I am going to deriving that equation. See, already we represented diode current at junction is hole diffusion current plus electron diffusion current, IPN of 0, hole diffusion current at junction plus electron diffusion current at junction. Let us, I am taking IPN of 0. This is the hole diffusion current, which is current A into current density, JPN. and A into current density. We know that current density is nothing but A in Q into, sorry, this is for holes, minus A into Q into dP into dP of x by dx. Okay, here dP of x, hole concentration at a junction, total hole concentration is this one, and this is under steady state hole concentration in n region. So P of x equals to Pn naught under steady state hole concentration plus amount of holes, injected hole concentration, P dash of 0 into e power minus x by Lp. E power minus x by Lp, the value of this one is P dash of 0 into e power minus x by Lp. Okay, e power minus x by Lp. We need dP of x by dx. Therefore, dP of x by dx is dP of x by dx is, this is constant 0 plus P dash of 0 into e power minus x by Lp is minus x by Lp, okay, into minus 1 by Lp. This is the value of dP of x by dx. So it is minus P dash of 0 into e power minus x by Lp by Lp. Okay, take this one, substitute here, but at the same time here we need at a junction, that means here it is at x equal to 0. Now at x equal to 0 it became, at x equal to 0 dP of x by dx at x equal to 0 is minus P dash of 0 by Lp into e power minus 0 is 1. Take this one, substitute here. Now you get here, so you get here it is IPN of 0. Therefore IPN of 0 is minus A into Q into dP into dP of x by dx at x equal to 0, it is P dash of 0 by Lp. So minus P dash of 0 by Lp. Now it is minus minus plus A into Q into dP by Lp, dP by Lp into P dash of 0, that is IPN of 0 value. Now we need to calculate P dash of 0. To calculate P dash of 0, I am going to using law of junction. So from law of junction, so law of junction is, law of junction, it is a PP equals to, okay, VT into, sorry, so our standard equation is, okay, contact potential V0 we written VT into ln of PP by Pn. So from this PP equals to Pn into ln of e power V0 by Vt. That is the law of junction. Okay, this is the law of junction, sir. So this is the law of junction. Now I am applying this one to open circuit junction. For open circuit case, in the open circuit, PP equals to, PP is hole concentration in P region. I am taking let P plus N junction, P plus N junction. Now so PP equals to NA, okay, and Pn equals to, under open circuit condition, Pn equals to concentration of holes in N region, Pn naught into e power, sorry, that is the value. From this I am writing Na, okay, Na equals to Pn naught into e power V0 by Vt, V0 by Vt. Let us take, this is the equation number 1 under open circuit. Now, but your diode is under forward bias. In forward bias, we can write PP is, see, whole concentration in P region, that is Na, and Pn is whole concentration in N region. Whole concentration in N region. Whole concentration in N region is, once it is forward bias, this is the whole concentration in N region. Okay, Pn naught plus P dash of 0. Okay, but compared to P dash of 0, Pn naught 0 is very small. You can neglect that. Now you can take this. So it is P dash of 0. From this too, you can write, see, P region is heavily doped. That's why P dash of 0 is greater than, since P dash of 0 is much greater than Pn naught. That's why I taken this. Now from this we can write Na equals to P dash of 0 into e power forward bias. Now it became V0 minus Vf forward voltage by Vt. Let us take equation number 2. See, now equation 1 and 2 both are representing the same Na. Now I am going to equating that. Therefore equation 1 equals to 2. So by equating that, there it is Pn naught into e power V0 by Vt equals to, this side it is a P dash of 0 P dash of 0 into e power V0 minus Vf by Vt. Just simplify this. So you can write it as P dash of 0 into e power V0 by Vt into e power minus Vf by Vt. So which is Pn of 0 into Pn naught into e power V0 by Vt. See, this V0 e power V0 by Vt, both sides gets cancelled. Therefore we got finally P dash of 0 is Pn naught steady state whole concentration in P region into e power, take this one this side, applied forward voltage by Vt. That is the equation for P dash of 0. Now take this one. Now therefore Ipn of 0 became Aq into dP by Lp into P dash of 0 is Pn of 0 into e power Vf forward voltage by Vt. That is the current equation. Now if you want, you can substitute the Pn of 0 value, no problem. This is the Ipn of 0. Similarly you can write INP of 0 is electron diffusion current in P region at junction, Aq into dN by Ln into Np of 0 into e power Vf by Vt. Okay, now the total current is sum of these two. Therefore total current is Ipn of 0 plus INP of 0. That's it. By combining this, you get the total current. Now I am moving to this problem. They want this current IN of 0, concentration only. Okay, so for that, just before we derived an equation for this P dash of 0. So we derived an equation for P dash of 0, electron amount of holes injected into N region, that is Pn naught into e power applied forward voltage by Vt. Same thing I am writing. Therefore, n dash of 0 is, okay, np naught into e power vf by vt. That is the value. Now, np naught value is electron concentration in in p region. So that is according to mass action law, it is Ni square by Na into e power forward voltage by Vt. So that is Ni value they given 1.5 into 10 power 10, 1.5 into 10 power 10 into 1.5 into 10 power 10 by Na 1 into 10 power 16. So 1 into 10 power 16 into e power Vf forward voltage 0.3 volts, 0.3 volts by Vt 0.025. Just simplify this. Now it is 2.25 into 10 power 4 into e power 10 power 4 into e power. Now just I am going to calculating that. E power, so it is a 3 divided by 0.025, that is 12. So e power 12, e power 12, shift e power 12, 1, see e power 12 it is. Now the next total value is, so into 2.25, that is 3.6 into 10 power 9 per centimeter cube. So this is the value you got, 3.6 into 10 power 9. So options 16, 17, now this is the option closest value. I think so the value change 3.6. Okay, here I taken it is e power 0.02. Just a minute, I will modify that. 0.3 divided by 0.026. So e power 11.53, e power 11.53 into 2.25, 2.28. So the exact value is 2.28. Okay, 2.28 into 10 power 9 per centimeter cube. See the difference is just here I taken 0.026 now for getting this value. Previously we taken 0.025. Take exactly 0.026. By taking that 0.026 you get this value, 2.28 into 10 power 9 per centimeter cube. So approximately 2.3 into 10 power 9 per centimeter cube. So this is the concentration. See this. So better to use non-words value of Vt is, if they mentioned it is 2.25 milli, then go for 25, otherwise take 26. That is the option. And clearly, clearly they given kT by q, Vt value 26 milli, but we taken 25. So now we taken 26. Finally we got the exact value. Is it okay, sir? So like that you have to solve the problem. So this is the beautiful problem, and you observed or not, in this problem is completely designed or framed based on the intermediate equation what we get during the problem, during the derivation of the diode current equation. So parallelly we derived the current equation for PN junction diode also. PN junction diode current equation also we derived. See this. Here it is. Okay. So intermediate value they taken, they designed the problem on that value. So because of that, you need to practice the complete derivations also. You may ask one thing, sir, but in GATE examination they provide only 3 minutes maximum for a problem. So it takes more time to derive the equation. You may ask like that. See, once you prepare the derivation properly, hardly it takes 3 to 4 minutes. This derivation takes hardly 3 minutes. Once you thorough the concept properly, okay, it takes hardly 3 minutes for derivation, this would derivation. Okay, so once you complete the equation, you get the equation within 3 minutes, within 1 minute you get the remaining part. Okay, so my dear students, for this type of problems they give minimum 2 marks to you, minimum 2 marks. So we have only 2 problems, 1 mark and 2 mark. Now you get 2 marks for this. So for 2 marks, spending 1 minute excess is reasonable. Okay, so once you get this equation if you know, hey, just check this, how many steps it is, only 3 steps. So within 3 steps you get the solution. Okay, so because of that, every one of you should practice complete derivations also. Okay, now we are moving to next problem. Yeah, see this. Consider an ideal silicon PN junction with Na 10 power 18 per centimeter cube and Nd 10 power 16 per centimeter cube. The layout area of the diode is 10 power minus 4 centimeter square. Area, sir, the area of the silicon diode they given 10 power minus 4 centimeter square. Calculate the junction capacitance, depletion capacitance at T equals to 300 Kelvin. Assume Ni equals to 10 power 10 per centimeter cube and dielectric constant of silicon is 11.8. Okay, see, they want junction capacitance. How much? We know the equation for this. Junction capacitance is epsilon A by D, means depletion region with W. Here they did not mention any information related to the biasing. That's why you can consider your diode is under open circuit condition. Now we need W0, depletion region width under open circuit condition. And one more, epsilon value, we know that 11.8 they given. Now epsilon is 1 into 10 power minus 12 farad per centimeter. And area they given 10 power minus 4. Area we know, epsilon we know. Now W0 you need to calculate. To get the W0, this is the equation for W0. Square root of 2 epsilon by Q into 1 by Na plus 1 by Nd into V0, contact potential V0. Now we need to calculate V0, contact potential. Vt into Ln of Na into Nd by Ni square. Okay, now just take this value, substitute here. Now I am going to first calculating V0, contact potential. So contact potential V0 equals to Vt into Ln of Na Nd by Ni square. Na Nd by Ni square. Now simplify this. Vt value you can take 0.026 into Ln of Na 10 power 18, Nd 10 power 16, 10 power 18 into 10 power 16 by Ni square 10 power 10 into 10 power 10. So this is 10 power 20, this is 10 power 14. Now it is 0.026 into ln of 10 power 14, 14 into ln of 10. Ln of 10 is, we know that it is 2.302. So that is the volts. Now its value is 0.026 into 14 into 2.3, that is 0.837, 0.837 volts. So far we calculated V naught. Take that V naught, substitute in this equation. Okay. Now I am going to calculating W naught. So W naught is square root of 2 epsilon by Q into 1 by NA plus 1 by ND into V naught. So its value is square root of 2 into epsilon value 10 power minus 12 by Q 1.6 into 10 power minus 19 coulombs into 1 by NA 10 power 18, 1 by plus 1 by 10 power 16 ND into V naught 0.837. That's it. Now I am going to simplifying this. Therefore W naught is square root of, see this is a 12, this is a 10 power minus 7, and it is a 2, it is a 0.8. So there you have 0.837, 0.837 divided by 0.8, approximately 1.04. Square root of 1.04 divided by, here 10 power minus 7 into, taking 1 by 10 power 16 common, 1 by 10 power 16 common into 1 plus 1 by 10 square, 1 by 100, 0.01. Okay, so it is minus 7, it is 10 power 9. Okay, so once it is 10 power 9, so into 10 by 10, it became 10.4, and it is a 10 power 10 square root. Now I am taking this one outside, it became 1 by 10 power 5 into square root of 10.4 into 1.01. So 10.4 into 1.01, square root of this, it is 3.24. 3.24 into 10 power minus 5 farads. Okay, that is the value of capacitance. 7. It's okay. So that is the value. Okay, sir. So here units may change. Units are default. So just a minute, I will check once again the units value. So 2 epsilon 10 power minus 12, 1.6 10 power minus 19, fine, it is 10 power minus 7. So 1 by 10 power 18 plus 1 by 10 power 16, 0.837. So 2.8 times 1 by 10 power minus 7, 10 power 16 common, 1 plus 1, 1 by 100, 0.01, 1.01, 10 power minus 7. So 10 power minus 7, 10 power 16. So 10 power 9. Okay, so 10 power 9, and it is 1.04. So 10.4 into 10 by 10. Okay, so into 10, here 10. So 10 power 10. Taking that 10 power 10 root outside, it became 10 power 5. Square root of 10.4 into 1. So it is 3.24 into 10 power 5, 10 power minus 5, sorry, 10 power minus 5 farads, or 0.324, sorry, 32 point. I'm going to representing that one in terms of microfarads. Okay, into 10 by 10. So 32.4 microfarads. Microfarads. Not this one. 32 point. Option is 32.4 microfarads. 32.4 microfarads. That is the answer. Okay. So some problems may not match exactly with the answer. Okay, don't worry. So we are following the procedure properly or not, that is the main intention here. Okay, so sometimes previously we observed I taken 0.025 25 millivolts for VT. Okay, but in problem they given 26. So due to that little bit small type of modifications, a little bit deviation in the answer, that's it, not more than that. Okay, now so these are the values. Sorry sir, we calculated sorry sir, we calculated only depletion region width, not sorry, we calculated only width, we need capacitance. Sorry, problem is not yet completed. So this is centimeters. Sorry, now we need to calculate capacitance. Sorry, capacitance we need to calculate, but capacitance is, this is the capacitance value. So Cj is epsilon A by D W naught. Epsilon 10 power minus 12, area 10 power minus 4 by depletion W naught 3.24 into 10 power minus 5. Okay, so it is, cancel in this, it is 10 power minus 11. 1 by 3.24. 1 divided by 3.24. That is 0.308. 0.308 into 10 power minus 11 farads. Can also write this one is 3.08 into 10 power minus 12 farads. Minus 12 means picofarads. 3.08 into 08 picofarads. Picofarads. That's it. 3.08 picofarads. So you got the value. 3.8 means 3.1, you can take approximate value. Okay, sorry, I think so it is a width, but it is farads, a little bit confusion. Okay, so my dear students, be careful while solving the problems. Okay, see the problem or study the problem once, twice if required. Okay, so first we calculated the depletion region width, sorry, contact potential V0. After that we calculated the depletion region width, and after that by taking that value we substituted that value in the junction capacitance. Total 3 steps applied in this. Okay, after that we got the exact value what we have. So now I am going to the next problem. See, consider the charge profile shown in figure. Okay, this is the charge profile they given, that means rho v they given. Charge profile means charge density, rho v they given with respect to distance x. From this we can conclude it is a uniformly doped diode, and this is the p region and this is the n region. Already we used this plot while calculating the junction electric field, and this value is minus Na into Q, and this value is a plus Nd into Q. Now the resultant potential distribution is best described by, see, the potential between these 2 points is going to be the contact potential V0. Okay, you get the electric field for this one is like this. This is the electric field you get. for this. It is a linear one. Okay. Now once you know the electric field, now potential is integral electric field. Integration of straight line, integral of x is x square by 2. It is a parabola. Okay, and from here to here it is going to be 0, plus you get some constant here. Due to that, from this region to this region, potential is constant, not 0. Constant, not 0. But in this plot here they given it is parabola. Here to here it is correct, but from this point they given it as 0. 0. That's why this is wrong option. And this is completely wrong because it is not a parabola. And this is also completely wrong because at this point at junction, from junction onwards it is exponential. So it is a parabola like this. It should be. Now it is a parabola. At the same time it is constant. After this point it is constant. It is not equals to 0. That's why option is correct option is D for this. Okay. Next. See, a germanium diode has a reverse saturation current of 30 microamps at 120 degrees centigrade. Reverse saturation current, that means I naught, 30 microamps at a temperature of 120 degrees centigrade. What are its dynamic forward and reverse resistances for a bias of 0.2 volts at this temperature? Sir, dynamic forward resistance and reverse resistance. See, dynamic forward resistance RF is written as eta Vt by Id. Diode forward current Id is here. So it is a germanium. You can take eta is 1 for that. Eta is 1 for that. So RF is eta Vt by Id. So we need forward current. In reverse bias, reverse dynamic resistance is eta Vt by reverse current I naught. Reverse current I naught. First you need to get the Vt value. So Vt is nothing but a Kt by Q. Kt by Q. Okay, and it is a T by 11,600. So the given temperature 120 degrees centigrade. At that time T is equals to 273 plus 120. So it is 393. Therefore Vt at 120 degrees centigrade is 393 by 11,600. So it is 393 divided by 11,600. That is 0.0338 volts. That means 33.87 millivolts. Here 7 millivolts. That is the value of Vt. Okay, now once you know the Vt, so we know the Vt and eta value is 1, we know it. Now we need diode forward diode current. So I am going to diode current. Now diode current ID is, we know that I naught into e power Vd by diode forward voltage by eta Vt. Okay, -1 is negligible compared to this. So I naught they given 30 microamps 10 power minus 6 into e power Vd 0.2 volts by eta is 1 into Vt value 33.87. Now I am taking that one also in volts. 0.03387. So which is 30 into 10 power minus 6 into its value is 87. That is 5.9. 5.9, sorry, e power 5.9, e power 5.9. So e power 5.9, 366, 366.84. So now it is into 30, into 30, that is 113. So 11 milliamps approximately, 11 milliamperes. That is the diode forward current ID. Now just go and calculate one by one resistance. First I am calculating diode forward dynamic resistance. RF is eta Vt by Id. So eta is 1, Vt value just we calculated 33.87 milli by Id 11 milli. Milli gets cancelled. So 33.87 by 11. 33.87 divided by 11. That is a 3.07 ohms. That is the forward dynamic resistance. And reverse dynamic resistance is eta Vt by reverse saturation current I naught. So 1 into 33.87 by the reverse current they given is 30 micro 10 power minus 6. It is milli 10 power minus 3. It is 10 power minus 3. Now it is 10 power 3. Okay, now just I am dividing that 33.87 divided by 30. That is 1.129. 1.129 into 10 power 3. 129. 10 power 3 means kilo ohms. So this is the diode forward dynamic resistance and diode reverse dynamic resistance. Okay, like that you can calculate the values. Okay, so my dear students, please concentrate on the problems also. You have to give equal priority to problems also. Okay, and if you want to say strictly in competitive point of view, you have to give high priority to problems. Okay, so thank you, thanks for spending your valuable time with us. So next session we go to the remaining problems. We have plenty of problems. Next session we concentrate on the remaining problems. Okay, don't miss this session, and thank you, thanks for spending your valuable time with us. Don't forget to use my code VRAW10 during subscription. Okay, and hit the bell icon for getting notifications, and please join our Telegram group to get the latest updates on of our upcoming videos. And don't forget to subscribe our channel, and please give your valuable comments on YouTube. Okay, to strengthen ourselves, to provide us energy to us, these comments are required. And once again I am welcoming you all to India's largest online learning platform, Unacademy. Thank you very much. Thanks for spending your valuable time with us.